So I'll say this. In the this or that, I'm putting this or that in quotes because you're not going to see it that way in the textbook. I might be the only one who describes it that way. So in the this or that probability problems, the event we are describing with two categories. Can be one of two things. It could be two mutually exclusive categories, which would mean there is no overlap. Mutually exclusive would mean no overlap. Or it could be two categories that are not mutually exclusive. So there is overlap. My two previous examples would be the pick a card, pick one card from a deck of 52, so we had this question, find the probability the one card is a 2 or a 3. Find the probability that the one card, and I keep stressing one card, one this, one that, because of what's to come a little bit later. So find the probability that the one card is a 2 or a 3. That event, a 2 or a 3, they are mutually exclusive. No overlap. I'll write that in red. Okay. A 2 or a 3. Mutually exclusive. Here's another example. I'll just say this one without writing it out. So, some of the problems in the work, they say, we want you to pick a person out of a group of people. So let's say we have, in a group, every football player who's currently playing in the Southeastern Conference. All of them. All the teams in the Southeastern Conference. Every football player. We're going to pick one person from that group. Can we pick a player who plays for both LSU and Alabama? Is there any overlap? No. That would be two mutually exclusive groups. I cannot pick a player that's playing on both teams. Now my other example, find the probability that the one card is a red card or a 9. Well, we have some overlap there. We have a red 9. We have 2 of them. So the 2 red 9s are in both categories. So these are not mutually exclusive. So there's a formula for each one. I'm going to write them up here. We'll look at a few more problems. There's a formula for each one. If 2 events, I'll write this up. Formulas for this or that. So my this or that, I'll call this event A, that is event B. This we'll call event A, and that is event B. And so if A and B are mutually exclusive, if A and B are mutually exclusive, and in some of the stuff, they'll use the word independent for mutually exclusive. Then the probability of A or B is, well, I'm going to write it P for probability, parentheses, A or B equals the probability of A plus the probability of B. Now on my problem where I said pick one card, find the probability you pick a 2 or a 3, I worked it out and I just said, oh, there's 4 2s in the deck and there's 4 3s, and I could say, well, there's 8 successes, 8 over 52, reduce it, and we're done. You could do it that way. If I use the formula, it would look like this. So I'll write pick one card. So the probability of a 2 or a 3 is the probability of a 2 plus the probability of a 3. All right. The probability of a 2 is 4 over 52. And the probability of a 3 is 4 over 52. So I can just add the 2 fractions, and I get 8 over 52. That does reduce to 2 over 13. So you could do it like that, or you could do what I did a little bit ago. How many 2s, how many 3s, and work it that way. For the events that are not mutually exclusive, the formula is a little different. Let me box off this formula. And now we'll do if they're not mutually exclusive. If A and B are not mutually exclusive, so there's some overlap. They might have used the word dependent. Then the probability of A or B is P for probability. A or B is the probability of A plus the probability of B minus the probability of both. Probability of A and B. Now, in my little card example, I'm going to put that up here shown with this formula. I'll write again, pick one card. I keep writing that because sometimes in the math problems, you kind of have to read between the lines. What did the author intend in that problem? So I'm trying to take that out. So the probability of red or a 9, if I work it with the formula for the overlap, the probability of red is 26 over 52 plus, now the probability of a 9, that's 4 over 52. And I hope you're thinking, there's a problem in there. I have counted the red 9s twice. I counted them in the reds and I counted them in the 9s. So what we do is we subtract it out once. So the 26 over 52 is the probability of red plus 4 over 52 is the probability of a 9 minus 2 over 52 is the probability of a red 9. So there's my two formulas for if they're mutually exclusive or not mutually exclusive.